Alright guys, so today we're going to learn how to add and subtract polynomials. So let's just take a second and review what we know. So it might be a good idea to pause the video now and try these problems. I'll do the first one. It says f of g of -1. Remember, that means that you take -1 and you plug into g first. You always plug into the innermost parentheses first. So g is x minus 3. So I'm going to take that x and replace it with -1. So we get -4. Now I have to take my -4 and I'm going to plug into f because that's the second one. So I'm going to take f, which is x squared, this one right here, minus 2x, and I'm going to plug in my answer of -4 that I got from the first one. Okay, so this is 16 plus 8, which ends up being 24. So that would be my final answer. Okay, so I went ahead and finished the second one and the third one. I know sometimes this last one might be a little bit confusing, okay, but when we review eventually for a unit test, we can go over those ones again. All right, so some important terms to know. Polynomial, okay, we're going to be adding and subtracting polynomials throughout. We're going to be multiplying polynomials, dividing them. Okay, all it is the sum of monomials. Okay, monomials are single terms. So an example of a polynomial is x plus 2. This would be, in particular, would be a binomial. It's still a polynomial, but specifically it's a binomial because it has 2 terms. Then the next two are trinomials because they have 3 terms. Something we've already kind of mentioned just while doing the evaluating of functions, but something you know hopefully fairly well, like terms. They're terms that have the same, there's a little bit missing here, okay, same variable to the same exponent. Sorry, I'm writing with a new stylus and it's taking me a little bit to get used to. So some examples of like terms would be what you see here, 3x and 5x. They both have an x to the first power. -6x squared and x squared both have the same letter to the same power, or the same exponent. -12r to the fourth s cubed and 5r to the fourth s cubed have the same variables to the same power, like terms. This is just review. I would pause it here and I would try to see if you can place them yourself. Okay, there's a shape for xy squares, there's a shape for x squared y squareds, and a shape for x squared y, and it says place the terms in the appropriate shape. So I'm going to pause it, I'm going to place them, and then we'll talk about why we placed all of them where they are. Okay, so I couldn't fit everything in each box, so what I did is I color-coded it. All the red ones go in the first one, xy squareds. All the blue ones go in the second one, x squared y squareds, and all of the green ones go in the last one, the x squared y's. The only ones that cannot be placed are 6xy and -2xy. Okay, they're like terms, but there's no box for them, so they would be out on their own. And the big thing about like terms is that we're able to combine them. So just using these as an example, if I have 6xy's and I want to subtract 2xy's, I just take my coefficients and I combine them. 6 minus 2 is 4, so I would have 4xy's. Okay, so this just says perform the indicated operation. So there's a combination of pluses and minuses in between. So when we're looking at a string of monomials like this, okay, polynomial, we want to combine our like terms. So we want to look for variables to the same exponent. We have an x squared minus 3x squared. And we also have to remember that when we don't see a number in front of a variable, it's always assumed to be a 1. So we've got 1 minus 3, which is -2. We keep the variable the same. So we combine our coefficients and we keep the variable the same. Then I have a positive 5x plus 7x. We have 5 plus 7, which is positive 12. We keep the variable the same. So my final simplified answer would be negative 2x squared plus 12x. For example 2, I've got 4x minus 4x. So 4x minus itself gives me 0x, or just 0, okay, which is essentially nothing. And then we have negative 5y and positive 6y. So negative 5 plus 6 is positive 1y. Okay, you would most likely never see the answer written like this. A 0x, okay, is just 0 times anything is 0, which is nothing. And then 1y is simply y. So this whole thing just simplifies to y. So adding polynomials is simply combining like terms. So is subtracting. Okay, subtracting just has an added step, or the way I teach it has an added step. So this says find the sum. Sum, you should know, means addition of this polynomial and this polynomial. So what I'm going to do is I'm going to write the first polynomial like this plus the second one. Okay, and I don't necessarily need these parentheses for addition, because with addition the order doesn't matter. Okay, meaning if I do 5 plus 3, I get 8, and 3 plus 5, I get 8. So it doesn't matter. Okay, these parentheses are a little bit meaningless for addition. So I have to combine my like terms. I have x squared plus negative 2x squared. Okay, so 1 plus negative 2 is negative 1x squared. Then I have negative 2x plus positive 2x, okay, which is 0x, okay, which we're not going to end up writing in our answer, but I'm just showing you that negative 2 plus 2 is 0. And then we have negative 3 plus 4. Okay, so that ends up being positive 1. So my final answer, okay, or my best, nicest answer, I wouldn't even put this one here. I can, it's not going to be wrong. I'm going to eliminate the 0x, and I'm just going to put 1. So subtracting is really just combining like terms as well. However, this subtraction, okay, if you're not careful, it can mess things up. So the way I like to teach it is I say keep, change, change. You're going to keep this first polynomial the same. You're going to change the subtraction to addition, and you're going to change the sign of everything in this polynomial. Okay? So what that looks like is this. I'm going to keep 5x minus 4y like that, and I'm going to change the negative to a positive here, or this subtraction to addition rather, and then I'm going to change the positive 10x to a negative 10x and the positive 2y to a negative 2y, and I'm going to do what I did in the previous one. 5x plus negative 10x is negative 5x, and then negative 4y plus negative 2y is negative 6y. Okay? It's also the same as just taking a negative 1 and distributing a negative 1. That's really all I did here when I changed the signs. Okay, so however you want to look at it, okay, it's exactly. Okay, so we will do an example of an addition and a subtraction. Again, the parentheses don't mean much for addition, so I'm just going to actually rewrite this without the parentheses, okay, because they're not really necessary. It doesn't change what we do. And again, I'm trying to get used to writing on this. Got negative 4x plus negative 3x squared. Negative 4x squared plus negative 3x squared gives me negative 7x squared. Then I have negative 5x plus 8x, which is positive 3x. And then last but not least, I have 7 plus negative 1, which is positive 6. So this ends up being my final answer. Again, if you have to pause and rewind, please do that. Okay, so another subtraction one. Again, I'm going to keep change. I'm going to keep the first one the same. And I'm going to change the subtraction to addition, and I'm going to change this negative 2x y squared to positive 2x y squared, and then I'm going to change this to positive 4xy. Now this one's a little bit more tricky because I added in x's and y's to each term, so I have to be careful when I'm looking for my like terms. I've got negative 1xy squared and positive 2xy squared, which gives me positive 1xy squared. Again, if you need help with that, just ask. Positive 3xy and positive 4xy, which is positive 7xy. And then lastly, I just have this. I have nothing to combine it with, so I bring it down to my answer, 2x squared y. Okay, so it's a big answer, but it's a simplified answer. Okay, so now you're going to go to Delta Math and try those problems. Okay, let us know if you have any problems.